I never look good.
Actually, yesterday you look better with that thing now.
Oh, I think so too.
Can this be the new screen?
So we're gonna write down and rewrite these questions. What I'm gonna do is, this is the things that you can make this function. So decimal can actually make math come alive in this instant. Okay. So we're gonna go through this question by details. So I'm gonna rewrite those questions here. Can somebody tell me the equation?
No,
F of
it's
x
your race.
is equal to what?
X plus 1.
X plus 1.
And then x squared plus bx.
So what is the condition here?
1 is less than x, which is less than 2.
So it's like this?
Yes.
There's no equal sign anywhere? No, okay, what's the next one?
X squared plus bx.
X squared plus bx plus c, and then this one is what?
Absolute value of x minus 2 is greater than or equal to 1.
Greater or equal to 1. So the way they've written this question is very, very difficult to read. This is a piecewise functions, and then the condition is going to be its absolute value. Okay. So now we have this function. So we want to make sure we find the value of b and c to make that connection of all three lines. That's so difficult, right? It's like, I don't think you have spot a second that we're not the exact same line. And you might have, I don't know. The likely of that happening, even go through a whole period, it can probably maybe one time. And it's going to be a split second, it's gone. Okay? So this three line has to connect together all exactly at the same time due to the b and c is changing. But this is what we're going to make it math work. Not just only saying, oh yeah, this is what it looked like, but I don't know how to make it math work. We're just going to wait, like Maya did. She's sitting here yesterday. She said, are they going to touch each other?
But it was hard.
Are they going to touch each other? Are they going to touch each other? Should I just wait for it? Right?
Everyone, you're the only one.
Don't feel special.
But the problem is, you can wait there forever, and the likelihood of that hit is very, very slim. So let's figure out multiple parts here. First of all, the condition here, this is called domain restrictions. Today's homework, those of you guys, you're gonna do today's homework is gonna go back to Algebra 1 and do a piecewise homework. And those piecewise homework is fun. Today is the only homework that's gonna be fun. I promise you, it's fun. Okay? So it's gonna be on computer as a marble slide. Most of my student does it before. So my student don't have to do it in the past, he already done it. But the only one condition though, the condition I want you to do is, make sure your equation not in the slope-intercept form. It's in point-slope form. Okay, point-slope form. Today's homework, make sure you do all your equation in point-slope form. There's a reason for that. Point-slope form is more powerful than slope-intercept form. So here, we can go back to talk about this one. Just even the condition was difficult. This is called domain restriction. So we're going to look at this domain restriction. We're going to say, okay, let's figure out what a restriction means. So this restriction, I'm going to do it on this side. So it's going to be this side. So x minus 2 is less than equal to 1. This is called absolute inequality. So when you do it, it's like, I told you guys that with absolute value, this is a question that's on SAT all the time. You just have to keep one thing, drop the parenthesis, drop the absolute value, and set it away as just exactly is without absolute value. Now the other one, this side is called a keep. Okay, and this one's going to be flip and change. So it'll be x minus 2, flip an inequality sign, and then change the sign here. And you're going to solve for both systems, so it's going to be what? X greater than plus 2, so it's going to be 3. And this one's going to be what? X less than what? Plus 2 is going to be 1. Does that make sense? So now piecewise, I'm going to rewrite in this way. F of x I'm gonna write an order. For less than 1, I'm gonna use this equation, so it's gonna be x squared plus bx plus c when x is less than 1. When it's x plus 1, it's gonna be 1 less than x less than 3. And at this part, it's gonna be x squared plus bx plus c when x is greater than 3. So I write in order from left to right. Okay, so now why do I do that? Because the function, you gotta pay attention to this point right here. This point that where they're connecting, you see that line just go by there? They have it connecting. But we had to make it 2 equations connecting simultaneously, same time. Not only one is connecting, you probably see it as something that's pretty close, but you had to make not only one point connecting, you had to make both points connecting at the same time. That's the hard part. So what are you gonna do? You're gonna treat this function.
I missed it.
So nobody pay attention to what I say. Everybody pay attention over there.
Coming back.
Wait,
Wait, mister, wait, coming back, coming back, coming back. It's caught.
Okay, this is more interesting than that.
Well, we like a graph.
This is more interesting than that. So you say, okay, let's make them connecting. So stop paying attention there.
Just pause them. You gotta pause them.
No.
You could have stopped it on the computer.
Yeah, why would you stop?
Oh, I could have stopped.
You're gonna watch that now, today.
Okay, so
You see everyone's facing that way.
so what happened is, okay, no, I didn't pull it down. Okay, so what happened is, I want to make this connecting. The only way is we had to use the limit process. And most of you guys, all of them did the work over there without limits. What I like about limits, because you actually understand how math works. I'm not training you guys how to solve a problem. I'm looking forward to train few of you guys become mathematicians in the future. So, although you're gonna laugh at it, but mathematician, if I train you guys how to beat the AP exam, everybody in this room can beat the AP exam. But if I train you to become a mathematician, then one day you can become a mathematician. You can change the math in the future. Okay, so I wanted more than that. So here's what I want. I want to say x approach to 1 from the left side. What equation I have to use? Those 2 equations, which equation I have to use? From the left side.
X squared plus bx.
So x squared plus bx plus c. Now they have to equal to, because they have to meet at the same point, the point that you were waiting for the whole time. So it's equal to limit x approach to 1 from the positive side. Which equation have to use? X plus 1, right? They have to equal each other. What happened when they equal each other? Connecting. Because limit didn't exist in that point. It's continuous. And due to this greater or equal to sign, it's defined also. Now I'm going to plug in 1 in here, but before I do that, I'm going to set up a second equation. Now there's a second gap. There's a second gap. Which gap was that? I'm going to pause it here so you guys don't pay attention there. Okay, so there was a second gap over there. The second gap is between this line and this parabola, this side. Where did that happen? X equal to what? 3. So limit x approach to 3 from the left side of this. Which equation I'll be using?
X plus 1.
It's x plus 1. It's equal to limit x approach to 3 from the positive side of what?
X squared plus bx.
Now why is limit is important? Because limit told you that limit approach to the left, it has to equal limit to the right. That's how a function is continuous. Are we okay here? So we had to make sure this part is connecting as well as this part is connecting. But mathematically, that's how the work has to be. Are we okay here? Okay, now the next part, just do the math. Okay, so Doc, can you flip the things over to this side so we can finish on this side?
Oh, I didn't really. Yeah, it's good.
So even right here is.
Yeah, you're good.
Yeah.
It's-
So
I
I
can see
here, I'm gonna plug in 1 into the function now. Limit x equal to 1 from negative, it has no difference, just plugging 1. So what would that be? 1 squared, right? Plus 1b plus c is equal to 2.
Whoa.
And then we're gonna plug in 3 in here, so it's gonna be what? 3 plus 1 is equal to 9 plus 3b plus c. Now we're gonna write on the bottom, so this one's gonna be b plus c is equal to what? 1, right? And then here it's gonna be 3b plus c is equal to, I'm gonna change it to this side, it's gonna be -5. Why do we do a system equation earlier in the year? Because here we do need to use it. So I'm gonna multiply this by -1 using elimination, so it's gonna be -b minus c is equal to -1. So that way it's gonna be 2b is equal to -3. b is equal to, my -6, sorry. And b is equal to -3. And c is, so b plus 1 is equal to 1. So it's gonna be, no, b plus c is equal to 1, so that's what -3 plus c equal to 1, c is equal to 4. Now let's go do the back to the math. So now what's cool is we know what a c value is. So which one you want to decide first, c or b?
Either, just make them connect.
Just make it one is connecting, so let's do c first, okay? We're gonna do c is equal to 4. And we're gonna let it play on this one. So now c is dictated. So c is in control, right? So actually now you have a chance that both connect same time, right here, right?
Wow.
So now we're gonna see how our hand-eye coordination is. Oh, it's not too bad, right?
Very
So,
Close enough.
Dang. Will you look at that?
That's really weird. Get a load of this.
Wow.
so what works? Sit there waiting for it to happen, or figure out what the real math?
But once that takes less time off.
I think you zoomed out.
I think the real math works, right? I think real math works. So the math is like this. Now, we're gonna do even better next time.
Make it differentiable everywhere.
We had to make it differentiable everywhere. Later on in chapter 2, we can talk about that. We actually make, right now, imagine if you have roller coaster on this graph, what will happen?
You die in the valley.
Right? We're gonna die horribly right here, right?
You hit like a wall.
Or you're gonna die this way, or going this one's fun, but this two part, how do we make a functional calculator, not functional, functional roller coaster?
Your slope has to be
Right now, it's not non-function roller coaster because you were broke, but it's doable, okay? But you're not gonna die horrendously, but you are still
won't
die
fall
on the
down.
track,
Yeah.
okay? But
Still
how
die.
do you avoid not die on the track? Are we okay here? Okay, so that's this lesson. Now today's homework is gonna be Algebra 1 homework, and then you have to make those piecewise functions. Make sure your piecewise function is in terms of point slope. Point slope is more powerful than slope intercept form. Okay, so can you flip to that side though? Okay.
Are you trying to get the board? The left
Yeah,
board?
that board. Yeah, that board. So now, so everybody understand this part?
Yes. Okay, I'm being in the way.
Okay, so you should be able to know how to do this problem. Now, is this problem on AP exam? Yes. It's on UCF when you go to
Wait.
UCF? Yes, because I went over the review for the UCF final exam, and I did like a live stream on it, and I go over all the questions, so I know which questions on UCF final exam. This is also on UCF final exam, on first exam and the final exam. Okay, so this is important. Now, yesterday we talked about intermediate value theorem. This is whatever you write down. This is the side that I write on the side. It says condition is continuous. FA does not equal to FB. Okay, FA does not equal to FB. There's a reason why FA does not equal to FB. K is between F of A and FB. So look, if this condition is not true, this condition will not be true. Because that value doesn't have to be between. Okay, so you have to be F of A does not equal to F of B. Okay, so here it does not equal to F of B. So you're gonna say, what is intermediate value theorem? Intermediate value theorem is gonna be like this. So this is the question. So I will actually show you the question first before I explain the theorem. The theorem is very common sense. So here's a water bottle. No, I'm not gonna break it this time. I know you are looking forward to that, but I'm not gonna break water bottle. But I'm gonna ask you a question. You're gonna zoom into the water bottle?
It was like zooming in your face.
Really close to your face.
Okay, so I'm not gonna break the water bottle this time. So here is the thing. Is it possible that I just drink top portion of the water and drink bottom portion of the water and not drink anything in between? So if you draw the straw, drink the bottom part and drink the top part, the thing's not gonna fall down?
It will fall down.
Huh? So is any way that after you drink it, right, only the water suspend right in the middle?
You got something under, something above it. He's saying more than drinking.
So it's not possible, right? Mathematically or reasonably, it's not common sense, intuitive, it doesn't make sense that you can do that. So it's also same as math. If you drink it, it will have to go through the center line. That's what intermediate value theorem said. So here's a question. The question says, prove that f of x equal to x cubed plus 2x minus 1 has a 0 between 0 and 1. Well, what do we know? X cubed plus 2x minus 1, that is what? What kind of function is that? Cubic function is polynomial, right? So do you know our polynomial has one thing in common? What is that thing? All the polynomial, doesn't matter, cubic, quartic, quintic, I think that's called quintic. They're all what? They're all continuous. So the first condition is automatically met because of the function. The second condition is between 0 and 1. So f of a 0, right? F of a 0, so we're going to plug in 0 here. The math is super easy. F of 0 is going to be -1. Is that okay? F of a 1 is equal to what? 1 to the third power plus 2 minus 1 is equal to 2, right? So you say, hey, I just proved it. Because there's a value at -1, there's a value at 2. It must go through the 0 at once. There is no way that I can, unless the function is not continuous. Right? That's the only way. Otherwise, it has to go through 0. 1 is at -1. This is a -1 value. 1 is at 2. And the function is continuous. If it's not continuous, intermediate value doesn't work. So you cannot say, oh, I decide to stop here and start going here. It's like I can drink a water bottle here, I can drink a water bottle here, but I don't drink anything in between. It's not possible because the water is continuous. So does that make sense? And that also doesn't have to be 0. I could have said it must have a value with 1. Why? Because -1 go to 2, it must go through 1. So in Precalc, the intermediate value theorem just says it has to go through 0 at least once. It can go to multiple times, by the way. But I hear it not only go through 0, it's going to any value in between. The k must be between at least one number, c and a, b, such that f of c is equal to k. At least one value, minimum. You can have more. You can have function going up and down, right? Oscillate 1,000 times. You can go through all this value in between. But as long as you have a value here and here, any value here is viable. Is that a word, viable?
Yes.
Okay. I'm trying to use the word I don't know. Yeah. Any question about this part? Okay, so that is intermediate value theorem. All you gotta do is plug in the end bounds for both. Okay? And then this is the most common missed question on UCF test. It's so easy. Everybody's like, I don't know how to do it. Yeah.
So is that gonna be an APs then?
Good question. I actually don't know. Because this is too easy for APs, but it's more on the pre-calc curriculum than the calc curriculum. Okay, so, but we'll still cover it because we're gonna talk about whatever we need.
Okay.
So therefore, you can have between 0 and 1, there's some value must happen between -1 and 2. So if you plug in both close interval, the endpoints in there, and you say 1 is 1, 1 is 10, it must go through 5. If it's continuous. Sorry, their function is not continuous. Right? Their function not continuous with a piecewise function. Asymptotes. Right? So they are possible to have that. How much time I have?
10 minutes,
10 minutes?
give or take.
Okay, so
Let's do 10.
we're going to talk about another core function. We're going to talk about another core function. This core function is called squeeze theorem. I mean,
Squeeze theorem. Sounds fun. Squeeze like what? Squeeze like what?
okay, we're going to talk about another function called squeeze theorem.
Squeeze.
So we're going to remember last time we asked you graph sine of 1 over x, right? So can you erase this part?
Sine of 1 over x.
We asked you to graph sine of 1 over x. Do you remember what limit do that exist at 0?
Yeah.
Yeah.
Oscillates too much.
It oscillates too much. Good. So the last time we asked you what is sine of 1 over x, right? We said the graph in the middle is going to be something like this, and it was like this, and it was like this. It's oscillating so fast, like we don't know what happened at 0. Okay? Just imagine I know karate or kung fu, I can punch so fast. So I go to my mom, I really don't like him, I start slapping, left and right, I slap so fast, and you can say at 0 seconds, which cheek did I slap? I'm moving so fast, you cannot know which cheek I slap you. So that's pretty much the oscillation. Right in the middle, right, is 1, -1, 1, -1, 1, -1, 1, -1, 1, -1. It was so fast, we don't know what happened at 0. Okay? I mean, you told me to stop. Which side I slapped you on? You were like, I don't know. It was too confusing. That's pretty much it, right? Now I'm going to introduce you new functions.
Oh no.
Oh no.
Squeeze.
So what if we have x to the times sine of 1 over x?
Is this a squeeze theorem?
So you say, okay, now it changed a little bit. It changes just tiny bit. I put an x in the front. I say, hey, can you tell me what happened when limit x approach to 0? Okay? And we say, we don't know what a graph look like. Right?
Like it's 0.
So what happened, we're going to use something called squeeze theorem. Squeeze theorem is cool. It's very, very cool. Okay, I think it's very cool, but none of you guys probably really think it's cool. But anyway, we're going to see what happened. So let's just treat it just this part. Sine of 1 over x. What do we say? We slap left, right, left, right, left, right. The value is always between what? Left cheek and right cheek, right? So in terms of math, it's going to be what?
1, -1.
1 and -1. Good.
I gotta take my intellect test off all the time.
Keep going.
Right? It's always going to be between 1 and -1. It's going to be left cheek or right cheek. There's no on the top of the head. There's nothing. It's a +1 and -1. Okay? So it's going to be +1 and -1. And you say, okay, but we didn't ask this function. But can I do this? Can I multiply all the side by x?
Yeah.
So I can say -x less than sine of 1 over x. X. See, did I make this function look like this one?
You did.
I multiply by x on all sides. Are we okay here? So now we say limit x approach 0. We're going to apply to here. We're going to say how limit x approaches 0. And this is called squeeze theorem. Squeeze. We squeeze everything, right? So now we say, what happens when limit x approaches 0? On this side. It's 0, right? Just plug in 0, right? And you can equal to, and this side is also going to be what? 0. Guess what? What's in the middle?
0.
Husband in that 0.
Whoa.
So now we're going to show you the graph.
What's in between 0 and 0?
Between the 0 and 0, there's no way to get any other value. But I'm going to show you how the graph looks like. It's more amazing than this. So
And hands. He's gonna grab me off.
So what happens if I have x
That's just the way it is.
sine of 1 over x
Oh.
Dang.
Dang, what?
Gotta go deep.
Yo, this is really trippy. Not gonna
Oh, Osprey's
lie.
last.
Ooh,
Oh, I didn't
ooh,
show this.
ooh. It now, Mister, now looks like a 3D hallway.
But it's squeezed between +1 and -1. It's squeezed so much because that x becomes there, so it's squeezed. Now we can draw two other lines. So y equal to x. That's the asymptote. Y equal to -x. Okay, so the blue line and black line, right?
Wow.
It looks like a 3D hallway.
So
It's going down.
So we're gonna draw a dotted line here. We're gonna draw a dotted line here, and we're gonna go out a little bit more. Do you see everything's regulated by the asymptote? The x and positive x and negative x. Look at here.
I just don't believe it.
The positive x and negative x. Can they see the screen or no?
Yes.
Yeah,
Yes.
I moved it.
So you can see that. And do they really touch that point? Can they touch that point?
You can zoom in and it won't.
It's an asymptote.
So let me ask you a question. Does this line ever touch that point?
No, it does not.
Yes, why?
Put less than greater than. Yeah, it's less than.
Ah, it can touch.
You did it right on the bottom.
Let me ask you to think of differently. What if I put an x squared here? What if I change this function to x squared? What will happen?
You have a parabolic. What's it called?
What happens if I change it to x squared over there?
Your limit would be the same, but like you'd have a parabolic asymptote, probably. I think. Maybe.
Will your asymptote change to a parabola?
I think it would, like two
Look, look, look,
one
look,
up and
look,
down.
look.
Look, I'll bet money on this.
This year
Getting
asymptote's gonna
still.
change to a parabola.
Or
Yeah.
not.
Or not.
There it is. From both sides. From both sides.
No one agreed
No,
to
no,
it,
no,
bro.
no, no, wait.
Oh, am I still right, bro?
Wait for it.
Hey!
Hey,
Hey,
ding, ding.
Pay up for what?
Hey, you're right.
I didn't do that.
Zoom that in.
Raphael, where's the money, bro?
It's oscillating because
Nobody
the
agrees
behavior
to
of
money.
the asymptote.
It
The
never comes.
asymptote of x in front of sine of x becomes the right thing.
Bro.
Okay?
Mr. Do X cube. Let's see that.
So you can change the q, you can change the x to the 4.
Crap.
I mean, it's a, that's it. See, I know my line. Okay, can you cross off? My nose broke.
Bro, I'm gonna watch when I get home.
Can you see my nose hair?
No, you have too bad of a camera. You need a better camera.
Again, all the stuff I'm teaching is not in the AP standard, but I'm gonna teach you, train you to become a mathematician, so.
It's just his mouth.
Bio, I wrote down the equation.
Should I end it?